When a user navigates to a modern corporate homepage, like the one we use at Royal Research, they are immediately met with a cohesive visual experience. Colors, typography, and layout work together to guide the eye. This visual presentation is the standard human interface for the web. We rely on aesthetic cues, heavy fonts for headlines, distinct boxes for sidebars, to parse information quickly and determine what matters most on the page. But if we strip away the CSS, the code language responsible for all visual formatting and layout, that cohesive aesthetic disappears. What remains is a dense, unformatted block of raw HTML code. This reveals a core operational reality of web architecture. The interface a human sees on a screen is entirely separate from the raw data a machine actually parses. Building an effective website requires looking past the visual layer. To control how a site performs in the digital ecosystem, developers must master this invisible, machine-readable data architecture. To test this, we can place two web pages side by side. To a human user, they are pixel-perfect identical. The layouts match exactly. Yet beneath the surface, their codebases are entirely different. Website A is constructed using generic structural code. Website B relies on a highly specialized, context-rich set of tags. Website B is actually utilizing semantic HTML. Standard code tells a browser how content should look. Semantic HTML tells the browser what the content actually means. Instead of using a generic tag to simply draw a box around a paragraph, semantic tags explicitly define the role of the text inside that box. When HTML was first created, early versions were primarily presentational, but as the volume of web data grew, engineers required a structured way to categorize information based on its role, rather than just its appearance. This creates a structural tension. If website A and website B look exactly the same to a human user, why do algorithmic search engines classify website A as unstructured noise and website B as high-value data? The answer is that semantic HTML operates as the true interface for search engines and assistive technologies. It provides the hidden mechanism that dictates both search engine optimization, or SEO, and overall accessibility. In generic code, developers rely heavily on tags like div and span. These are empty containers. They offer zero structural meaning to a machine, existing solely as blank hooks for visual styling. This diagram represents the document object model, the structural tree a browser uses to map a web page. Here, the Royal Research homepage is built entirely from identical div tags. When a crawler reads this, it scans the tree to extract data. Because the generic tags provide no internal hierarchy or context, the crawler's linear parsing algorithm extracts all the text with equal, uniform weight. To the machine, the primary article text, the footer's copyright string, and the top navigation links all hold the exact same value. This lack of contextual hierarchy diminishes SEO value. Without semantic markers, the algorithm cannot mathematically determine the primary subject matter of the page. It just sees a flat wall of text. Treating HTML merely as a scaffolding for visual layout yields a functionally broken architecture for any machine attempting to read it. We correct this by refactoring the codebase. This involves replacing those empty generic wrappers with modern semantic tags. Watch this generic DOM tree transform, replacing identical div wrappers with explicit tags. The header node isolates, signaling it contains the primary navigation. The article node detaches, showing the machine this block holds the core weight independently. Conversely, wrapping the bottom text in a footer tag designates it as a low priority zone for auxiliary information, effectively deprioritizing it. This prevents secondary data from diluting the value of the main content. Applying these semantic tags shifts web development from painting a visual picture into engineering a precise, machine-readable data architecture. This structured data architecture directly feeds the accessibility tree. The accessibility tree is a critical secondary data structure generated by the browser specifically to interface with external assistive technologies. This side-by-side technical layout shows the semantic DOM tree on the left. The explicit tags automatically populate the accessibility tree on the right, converting structural nodes into specific, navigable behavioral landmarks. Assistive technologies, like screen readers, completely bypass the visual CSS layer entirely. They are designed to interact exclusively with this new accessibility tree. Because the article tag generated a specific landmark in the tree, a visually impaired user can press a single hotkey, allowing them to instantly skip over a repetitive block of navigation links and begin listening directly to the main content. This exact same architectural logic applies to search engines. SEO algorithms rely on these identical semantic landmarks to assign indexing weight. A search engine crawler will assign high indexing priority to keywords found within an article tag. However, if those exact same keywords are trapped inside a generic div wrapper, the crawler assigns them far less indexing value. Semantic structure operates as the shared language. It is the single framework used by both accessibility tools and search algorithms to accurately interpret human intent. A single, effectively designed webpage must successfully serve three distinct audiences simultaneously. This three-pane model outlines the required outputs. Left, the human visual experience; middle, the SEO indexing structure; right, audio for screen readers. A single semantic element, like the article tag, dictates behavior across all three environments simultaneously. This architectural efficiency ensures that the core message of the website is preserved intact, regardless of the method a user or machine relies upon to access it. Semantic HTML operates as the primary bridge linking human-centered visual design directly to machine-level data comprehension. Correct semantic tagging serves a purpose far beyond simple code organization. This architecture provides the necessary technical foundation for global search discoverability and universal user inclusion. A beautifully rendered website remains functionally invisible if a machine cannot parse its internal logic. Engineering information with precision at the HTML layer provides the solid groundwork for every resilient, high-performing digital presence.